Hi everybody, back to Cook's Radio again. Today is it's Monday 18th of March. Last time I talked about the lab EL238 AC simulation of electrical circuits, or you're talking about frequency response of RLC series resonance circuit. And we also mentioned about the bandpass, filter. You have the characteristic like this. Okay, as you can see from the plot, and tell you how to calculate for F0 centering frequency, and then also high frequency cutoff or FCH, and then also low frequency cutoff or FCL. Okay, so it's going to be on the right, on the left of centering or the resonant frequency F0. And the relation of bandwidth and Q factor is the bandwidth equal to the resonant frequency F0 divided by Q. So let's get, since we already mentioned about a bandpass filter, let's get into more details about the meaning of the bandpass filter. The bandpass filter, or BPF, that's for the short, is the device that passed the certain range frequency and then rejects and also attenuates their frequency outside that range. Now we talk about the description. The example of a bandpass filter or electronic bandpass filter with the analog is the RLC series, or you're talking about resistor, inductor, and capacitor circuit. This filter can be created by combining the low pass filter and high pass filter. So that's how you get the bandpass filter. Bandpass is an adjective that describes the type of filter or the filter process or filtering process, which distinguishes from passband. In this case, it means that the actual portion of the spectrum that is affected. So we can say that the bandpass filter have two passband, and also the passband signal is the signal that containing the bandwidth that's not adjacent to zero frequency. For example, it's the signal that is come out from the bandpass filter. For ideal bandpass filter, is we have a flat passband completely. For example, there's no gain and attenuation, but we were completely or we will completely attenuate all frequency outside the passband. Additionally, the transition from passband is we have the brick wall characteristic. That means you stop the signal from getting in. In practical, there is no idealistic bandpass filter, and the filter is not attenuate or the frequency that outside the defined frequency completely. In particular, there's the region outside of the passband that are intended, and then attenuate the frequency but not uh, rejected. And this is known as the roll-off filter, and always or often expressed in the unit of decibel of attenuation per octave or decade. Generally, the design of a filter is trying to have a narrow roll-off as much as possible, allowing the filter function very close to the intended design. And often this is achieved by the expense of a ripple of the passband or the stop band. So that's the more details about the passband. The bandwidth of the filter simply is the difference between the upper cutoff and the lower cutoff frequency. And also the shape factor is the ratio of the bandwidth that's measured using the attenuation, the difference of the attenuation, two of them, to determine the cutoff frequency. For example, shape factor is like 2 to 1 at 30 or 3 decibel. It's meaning that the bandwidth measured between the attenuate frequency at 30 degrees will be a double of whatever that's measured between attenuation frequency at 3 dB. And also our optical bandpass filter, we can see here X-ray is common in photo show and light show or in the theater. This filter takes the form of the film or transparency. The next one is talking about the Q factor. You're probably get used to this one or be familiar with the term. The bandpass filter can be characterized by Q factor itself. Q factor itself is the reciprocal or the inverse of the fractional bandwidth. For the higher Q filter, that means you will have a narrow pass band, and for low Q filter, as you will have a pass band widened. This will be called the narrow band, the narrow frequency band, and the wide frequency band, respectively. Now let's take a look at the applications. The bandpass filter are used widely in transmitter and receiver, the wireless transmitter and receiver. The main function of the filter in transmitter is to limit the bandwidth of the output signal to allocate frequency for transmit signal. And then this prevent interfering to another station, and In the receiver, the bandpass filter allows the signal in the range that are selected to be heard or decode, while prevent uh, unwanted signal to get in. And also the bandwidth filter will also adjust the signal to noise ratio and also the sensitivity of the receiver to get the best out of it. Both function to transmit and receive the bandpass filter that has been designed. We have the appropriate bandwidth for mode and speed of the communication by increasing the number of transmitter in the system as much as possible, while we were decreasing the noise and the competition between the signal as low as possible. Now, what can info in the bandpass filter is when we are working with the sound system. So let's take a look at the speaker enclosure. The bandpass filter for the fourth order can be modeled by a vented box, which is the inner combination from the back of a speaker cone, which is trapped in the seal box, and also radiate from the front surface of the cone, and then passed that signal into the porta chamber. This will modify the resonance of the driver in the simplest form. The compost box, we have two chambers, and then the wall divided between two chambers will hold the speaker, and then only one chamber we have the port. If the chamber in each side of the woofer has the ports, this enclosure or the box will give the frequency response to the sixth order bandpass filter. This one is difficult to design and tend to be sensitive to the characteristic of a driver or speaker, as well as the reflect another reflected chambers. In general, the port we will replace by passive radiator if wanted. The bandpass box for the eighth order is another variation that has the narrow bandwidth, often used to get the sound pressure level, or SPL for the short. And in the case of a specific frequency of the bass, we use, uh, or apply to any kind of music. It is complicated to design and have to be precisely designed to work as intended. Now let's take a look at another fields of the bandpass application. In neuroscience, the visual cell is the first demonstrated by David Hubel and Thorsten Wiesel, which has the characteristic to response like a Gabor filter, which is also the bandpass filter. And for astronomic, the bandpass filter is used for light spectrum to allow only one part get into the equipment. The bandpass filter can help to look for star location in the main sequence, and also identify the redshift and another applications. Okay, sometimes it's like difficult to understand, but it just gives you another more details in the application of the bandpass in the real world. Okay, and then I'll explain to you later on. Okay, bye.